Welcome to the Watershed Learning Network. In this module, we will discuss green infrastructure. People often use the terms gray, green, and blue infrastructure when discussing watershed management in urbanizing areas. Gray infrastructure is the infrastructure we typically think about when we think about stormwater management, and that includes pipes, pumps, ditches, and detention ponds. Green and blue infrastructure, on the other hand, are all the natural and semi-natural landscape elements that we can use to mitigate stormwater flooding. So this can refer to individual rows of plants or trees, but it can also refer to large parks and urban forests. Blue landscape elements, which form the blue part of the infrastructure, are linked to water, and they can be pools, ponds, or even artificial watercourses like artificial streams that people can construct in cities to help mitigate floodwaters. There are many types of green infrastructure, and some of them include green roofs, rainwater harvesting, urban parks and forests, and rain gardens and bioswales. All of these are dedicated to reduce the amount of stormwater flowing over surfaces to prevent flooding. And many of them are reliant upon plants to be able to take up water and to allow and permit infiltration of rainwater into soils in urbanizing areas. Green infrastructure can provide many benefits, and here we are going to discuss some of the ecological, social, and economic benefits that communities can derive from implementing green infrastructure programs. We will begin by discussing some of the ecological benefits of installing green infrastructure. Climate change is affecting each community differently, but green infrastructure can carry a wide variety of benefits that can alleviate some of the effects of changing climate. As we'll discuss later in this presentation, one of the biggest benefits of green infrastructure is the potential reduction of flooding. In many places, climate change is predicted to increase the risk of drought and/or flooding by altering the timing and duration of rain events. By enhancing more natural flows and the recharge of water into groundwater, well-planned and well-constructed green infrastructure can reduce some of the effects of extreme weather phenomena caused by climate change in urban areas. The construction of green infrastructure also has the potential to restore some plant and wildlife habitat in urban regions. Small-scale projects can have benefits such as supporting urban pollinator populations, including bees and butterflies, and larger-scale projects, such as parks and greenways, can also provide important corridors wildlife can use to navigate through developed areas. Green infrastructure can also improve water and air quality by promoting infiltration of rainwater and stormwater runoff, and trees and plants can also absorb some particulate pollution and improve air quality in urban areas. Green infrastructure often provides additional ecosystem services or benefits people derive from nature. For example, as a result of the improved environmental conditions, green infrastructure can encourage more outdoor recreation and reduce some of the effects of air pollution. Furthermore, green areas such as urban parks and forests can also provide havens of cooler temperatures in cities during the warmer months of the year. Together, this can improve the health of communities living near and using green infrastructure. There are also many stories of communities organizing to improve their neighborhoods by supporting local projects to develop green infrastructure. It should be noted, without community involvement in the planning process and the establishment of an effective management plan after construction, a green infrastructure project may subject local communities to new ecosystem disservices or negative outcomes derived from nature. For example, the creation of a park can produce many benefits to human health and well-being. However, if the park lacks other services such as lighting, plumbing, or monitoring by the local government, it may fall into disrepair and/or become unsafe for the local community. Traditional gray infrastructure projects to deal with problems such as flooding are often justified by their low initial costs. However, when planned well and executed efficiently, the long-term costs of green infrastructure projects can be more cost-effective than traditional gray infrastructure development. When communities are involved with the planning, green infrastructure construction projects can also generate training programs to create a skilled labor force to maintain the quality and functionality of the green infrastructure project. As demand for these skills increases, there may be more opportunities to apply this skill set in other places. Many green infrastructure installments also have the added benefit of raising property values in an area. Houses near parks and with lots of trees and green space are consistently valued more highly than surrounding areas. It should be noted that if green infrastructure project planning does not integrate policies to address equity, the addition of green space into a neighborhood may lead to the displacement of local communities due to increased property values. Green infrastructure can be used to reduce flooding in urban areas, and this can be done at many spatial scales. Here we will present examples of property level, watershed level, and city level projects designed to introduce green infrastructure to reduce flooding. Remember, flooding issues are usually watershed specific. Different development patterns in a watershed will produce different flooding regimes. Climate also plays a key role in determining flood risk. Communities living in the arid climate of the southwestern U.S. will face different challenges that communities in the southeast or coastal cities threaten with sea level rise and increasing threat of storm surge. If you are interested in integrating green infrastructure in your home or community, consider working with local organizations, universities, or government agencies who are aware of the specific challenges your watershed may be facing. Residents can install infrastructure in their homes or apartment complexes. For example, in the Seattle area, residents, with the assistance of Washington State University and other partners, have installed 12,000 rain gardens in the greater Seattle region. These rain gardens not only beautify people's homes and add to their property values, they reduce the chance of their home flooding and contribute to the overall betterment of their local watershed. The construction of green infrastructure can be expensive. If you're interested in incorporating green infrastructure into your home, make sure to investigate whether there are any programs through organizations or the local or state government to support smaller individual projects. If such programs exist, they will often include access to experts that can aid in the design and implementation of your project. Green infrastructure projects can also be implemented at the neighborhood or watershed level. One such example is the Lindsay Street Park in the Proctor Creek watershed of Atlanta. Here, the community came together and partnered with several NGOs to build a public park complete with a rain garden. The Proctor Creek watershed suffers from severe flooding during storms, and the hope is that green infrastructure projects like these will help slow the flow of stormwater and reduce the impacts of flooding in the watershed. Cities can also engage in green infrastructure planning. For example, the City of Atlanta had a green infrastructure task force draw up a comprehensive plan for the city's green infrastructure development, and they are working to implement this throughout the city. One project that resulted from this plan is the Old Fourth Ward Capacity Relief Pond. Through a partnership between Atlanta Beltline Incorporated and the Atlanta Department of Watershed Management, a large area in the community was converted to a park with a stormwater retention pond, both of which are used to help alleviate the problems of runoff and flooding by slowly absorbing and/or retaining the water. The success of green infrastructure projects in mitigating flooding can be evaluated in many ways. Reduction of floodwaters and the reduction of time communities are subjected to flooding are obvious metrics. However, as we have mentioned, poorly planned projects can produce ecosystem disservices and generate problems with equity and displacement. Community involvement in the planning process, early implementation and enforcement of policies to promote equity, and a post-construction management plan are all essential components of green infrastructure projects that promote long-term ecological, social, and economic benefits to the surrounding community. If you live in a community that's frequently subjected to flooding, it's important to mention that the construction of green infrastructure projects may alleviate some, but likely not all of your problems. To establish effective flood mitigation projects, it's essential to plan green infrastructure development within the context of existing and planned gray infrastructure, for example, retention basins, culverts, etc. When possible, green infrastructure planning should be done at the watershed level in collaboration with hydrologists, or people who studies the occurrence, distribution, movement, and properties of water, engineers, and city planners. When thinking about effective green infrastructure, communities need to understand several things, including, but not limited to, 1, What are the projections of development and population growth within your watershed? And this is to address how much more impervious surface will be introduced into the watershed and where it will be introduced. Secondly, how is subsidence and sea level rise going to affect your city or watershed? In certain cities like Atlanta, subsidence or the sinking of the city may be affecting flood risk, but most likely sea level rise will not, as Atlanta is so far inland. In other places within the U.S. and throughout the world, that is not the case. And third, what are the current flood risks in your watershed, and how are they projected to change with increasing development and continued climate change? If you are concerned about these issues and want to know more, we would suggest trying to find local organizations dedicated to urban watersheds, the offices in your local government dedicated to watershed or stormwater management, and scientists at local or regional colleges and universities that study watersheds to learn more.